Today we are going to talk about homework 6, problem 1. The problem is capital X and capital Y have joint disunity function, and if capital XY xy equal to 1 plus xy over a, and 1 bigger than x, 1 bigger than y, and 0 otherwise. And there's 5 problem. Problem 1 is find capital A so that the above defined is a value joint disunity function. Problem 2 is are capital XY uncorrelated. Show your answer. Question 3 is are capital XY independent? Show your answer. And question 4 is find the joint density function of capital X square and the capital Y square. And problem 5 is prove and or disprove that capital X square and the capital Y square are independent. In the clues to homework 6, we can see for problem 1, they gave us the first 3 questions to answer. And for the problem 1, we get capital A equals 4. And for the question 2 and 3, we know that when 0 smaller than 0, z is smaller than 0 or z bigger than 1, and w smaller than 0 or w bigger than 1, if capital ZW equals 0. For problem 1, we can give integral from -1 to 1, integral -1 to 1, and 1 over capital A multiple 1 plus xy derivative x derivative y, which we can get 4 over a equal to 1, so we can get capital A equals to 4. And for the problem 2 and 3, we can do it together. So capital XY equal to integral from -1 to 1, integral -1 to 1, xy multiple 1 plus xy over 4, derivative x derivative y equal to 1 over 4 multiple integral from -1 to 1, integral -1 to 1, xy derivative x derivative y plus integral from -1 integral -1 to 1 x square y square derivative x derivative y. We can get the answer is 1 over 9. And then capital X equal to integral from -1 to 1, integral -1 to 1 x multiple 1 plus xy over 4 derivative x derivative y, we could get is 0. So capital XY is not equal to capital X multiple capital Y, which means capital XY are not uncorrelated, and also capital XY are not independent. And for problem 4 and 5, we also can do it together. So capital Z equal to capital X square and capital W equal to capital Y square, and then we can get J equal to absolute value 2x 0 and 0 2y equal to 4xy. So Z equal to x square, W equal to y square. So when Z bigger equal to 0, smaller equal to 1, and the W bigger equal to 0, smaller equal to 1, we can get absolute value capital J I equal to 4 root 2 root w, and I equal to 1, 2, 3, and 4. So f capital ZW equal to fxy root z root w over absolute value capital J1 plus fxy negative root z root w over capital J2 absolute value plus fxy root z negative root w over absolute value capital J3 plus fxy negative root z negative root w over absolute value J4. So we can get the answer is 1 over 2 root z multiple 1 over 2 root w. And when z smaller than 0 or z bigger than 1, and when w smaller than 0 or w bigger than 1, so f capital ZW equal to 0, and f capital ZW equal to 1 over 2 multiple root z multiple 1 over 2 multiple root w for z bigger equal to 0, bigger equal to 1, and w bigger equal to 0, smaller equal to 1, and 0 otherwise. And we can get f capital Z multiple fw w. With f capital Z, we can get 1 over 2 multiple root z for z bigger equal to 0, smaller equal to 1, and 0 otherwise. And f capital W equal to 1 over 2 multiple root w for w bigger equal to 0, smaller equal to 1, 0 otherwise. So x squared and the capital Y squared are independent.